It's the recording kind of midstream. If you're watching this video now, I hope that you're on a team of 3 or more already. If you're not on a team, use the chat box to try to put together a team from the people that are physically present. So I know Samuel Fernandez and Samuel Spalding, you're already on a team because you said you reported in class today. I think Ryder, you're on a team, and so on. So is there anyone who's watching the video now who has no team? You can answer that by unmuting yourself or typing in the chat box. I guess if nothing appears in the chat box, it means you're all teamed up. Excellent. Very good. We'll use this time to
apparently Parth and Christian don't have one.
Okay, so you two might want to join and then find a third person and declare yourselves a team. So, okay, Christian says wants to be on a team party. Perfect. Yeah, I think that would be fine. And just figure out a way to communicate with one another outside of this lab. Discord, WhatsApp, Slack. I don't know what all the newer apps for that kind of things are. And you should meet at least initially once a week. You don't have to do a physical meeting. You can meet electronically and then plan out and divide up the work to get the project completed. The project is a reasonably important part of the overall course grade. Let's go see what it claims it is. I think it's 15 or 20%, so it's a really good chance to try to move from a consonant to a vowel. A project is 15%, and we haven't had any quizzes, so I have to reapportion that 15% somewhere. I'll probably equally divide it between project and lab notebooks. So it's worth your effort to produce a non-zero project. Okay, cool. Well, I'm gonna mute myself and kind of monitor. Oh, actually, I guess I'm still God right now, so I can't mute myself and monitor stuff. Need to add everybody. All right, for the 2 recent joinees, if your team is present in the lab right now, use this time either using the chat box and direct messages to each other or even public messages to the chat box to organize your your project effort. Let me get back to here. So your main goal for today is to try to come up with a blank document that captures the features of this document here, and either do that in a word processing software, or if you feel so inclined, try to figure out how to do it in Jupyter Notebook. Here is the read the docs part for Jupyter Notebook that discusses ways to generate certain features in a notebook using the Markdown cell and the Markdown language. If you have no idea what we're talking about with Markdown language, this would be a bad decision. If that's the case, just do it in a word processing software, Microsoft Word or OpenOffice or LibreOffice or something like that. If you do use a word processing document, be sure that when you're moving the document around, you're actually moving the document and not hyperlinks back to OneDrive, because that becomes unobtainable for other people in email. So I guess that is move the actual document, not don't take any Microsoft features and say, let me move it for you because I'm awesome. We'll never get there. All righty, well, I will continue to monitor. That's today's lab. If you have questions, unmute yourself and ask the question. Josh will stay on the lab until 10 o'clock also, available to answer questions. We're probably going to do this one day a week for the remainder of the semester. So today it makes sense that everybody's absolutely silent. But starting next week and afterwards, you probably will have technical questions. At that time, that would be a great time to come to the lab, ask the question. Myself or Josh will attempt to answer it as best we can. And it's okay if we answer it publicly because it's likely that other teams have, if not the identical, very similar questions. Okay, Josh, I'm going to make you boss, and that way I can.
Okie doke.
But literally, you can every 10 minutes or so just make sure everyone's still alive until the time is over.
I think I can manage that.
Okay, let me
for an hour.
I think I have to stop screen sharing. It should allow you to take over host.
Yeah, I think I have it.
All right. And I have the recorder running, not that it's going to be very useful today, but being consistent with what we've done all semester, we'll keep the recorder running. So again, everybody, if you have questions, use this time as best you can to answer them. Today, your goal is to build that blank reporting sheet. And I've already created upload space on the Blackboard server for that, for this week's reporting sheet, which basically would be the sheet, your team member names, and that you met in lab, and you're going to try to figure out sometime in the next week who's going to do what and which project you're going to choose.
This one will be easy to grade.
Yeah, it'll be very easy to grade. But Josh, you do have a question from Mike. I will leave it to you.
Yeah, lab 25. Let's take a look.
Video.
Okay, let's see. This one? Yeah, you can share yours. At least I think I have it set up that way.
Can I also talk to the mic like this too, if that's possible?
Yeah, go nuts. It says all participants can share, so go ahead and try.
Okay. Can you see that?
Yeah.
Okay, so like on this part is I copied it exactly from the notes and the labs you did. And so it gives me that same X and Y error. I think you had it too in the lab, but I don't remember how you fixed it or not.
So scroll up to where that is. So that should be, let's go down a bit. I need to see where the arrow is. So it's, yeah, there on right after build a plot. So you need to check the size of your Weibull and the size of sample, see what they look like.
Where's that at? Okay.
So right here,
Gotcha.
those two things, where do they come from?
From up here, because this has nothing, right here, my bad. Sample one.
That's not where it's defined. We need to figure out where it's defined. So we're here. Okay. So go back down where you find the error. Print out like right here. Put like a print for the length of Weibull and print the length of sample.
Wait, what do you mean?
So go to your code, right? So that'll be here. Before this line, you need to put print the length of the Weibull. And then do the same thing for sample. You're going to need another parenthesis.
Appreciate it.
Okay. Okay, so if I remember correctly, 80 was the entire thing, right?
Mhm.
I remember seeing 25, so that only means that where you go in your make sample, you've told it to select 25 random elements. So either we want to change the 80 to 25 or the 25 to 80.
Mhm.
I think changing the 25 is easiest. So go to our samples to find. Yeah, right about there. And let's see. Can you copy those print statements? The ones you wrote down there? Okay, go back up to where we were. Paste that right here. And run it. Okay, so they're both 80. Okay, go down. So sample gets redefined somewhere.
Sample, sample mean. I'm just looking for sample.
Yeah, same here. Don't see it here. What you should be looking for is it on the left-hand side. So sigma. That is strange.
Perfect. Sample.
Put a space after that. It'll narrow it down for you. It's fine here.
Yeah.
And then it's getting redefined somewhere, and that's weird. So let's figure out where.
I'm not seeing anything too.
Yeah, me neither. Paste that right after here. No, down here, at the very end. All right, run it again. Okay, so go down. That means everything up there is fine.
Mhm.
So let's see if there's anything in this block that we don't like. That is so weird.
It's funny because I copied it exactly from the.
Paste here, but not inside of the loop. Yeah, try it again. Okay, scroll down. That is so weird.
Mhm.
It's as if when you make your figure, there's some variable called sample that is getting redefined. Either way, it's weird. So go up to where sample is defined, and we're just going to copy and paste that. Yeah, that.
And paste it down here.
Yeah, put it right above your prints. Yeah, right there. Yeah, that is weird. I have no idea why. Yeah, that's weird. Anyway,
I
so
believe-
that's that issue.
Yes, sir. I believe that's it. And then I'm just working on the rest of the homework.
Okay, cool. No
Yes, sir. Thank you.
problem.
Let me stop sharing real quick.
Yeah. What's up, Parth?
Is it okay if I speak?
Sure.
So I could never actually figure out this part, the log model.
Um,
I don't know what I'm doing wrong.
so let's see. This is 24. Is this the, okay. Is this the step 3?
Yes.
So let's see. There's nothing crazy different. I don't even think that this has to be in log space, but you see where your function is in step 2, it's B0 plus B1 times TDA.
Yep.
The only thing you have to do is put a log around that TDA.
I think that's like this, right?
I believe so, yes.
But this is all I get then. And whenever I mess around with the values, it's just the same equation I get.
If so, if you look at the lesson, you can, let's see. If you look at lesson 24, that's what I'm looking at right now. Let me. I'm just doing running this on my machine so I can see.
Mhm.
Yeah, I was thinking in lab 25 was where we did the log thing. One second. If you so in lab 25 or not in lesson 25, if you go to like log normal, it's under probability estimation modeling, Beargrass Creek. You'll see the top like 5-6 lines are what transform this whole thing into log space. I'm trying to do that right now.
Like this part.
Yeah. Because the thing is, when you do a logarithmic fit like this, I don't know, that is kind of strange. Should look a little better.
I tried messing around with the bases as well. That didn't seem to do anything.
Well, so if you go to the lesson, the reason it looks so weird is it's explained is when we apply this log function and then we get our data, we have to undo the log in order to make it look not terrible, which is the next thing down. So go down.
Oh.
Yeah, see, this is where it's, we did all the log stuff. Now we're transforming it out of that. So it looks nicer.
What do you mean by transforming it back?
This right here is the inverse of doing a log. So I've got my item, I apply a log to it, I do whatever I want to it. I undo the log by doing this here, and then I get the item back. So
So what values are we graphing? Like on the what are we plotting?
here it's I don't remember the top of my head. It looks like the the actual data is in blue, and then the fit is the red line. So it looks like backwards from what we have colored.
I still don't get why we're taking the anti-log. So we take the log values and then we plot that on the graph. And then we take,
Here, I'll try to explain it to you. We have a process called regression, right?
Yep.
It lets us try to get the line that'll go through all the data. Well, I tried doing it normally up above, and that got us whatever. I want to try using a logarithmic approach to doing that. But in order for me to do that, I have to take all my data and apply log to it. And that takes us into log space. So log, take us into log space, and then we'll do our regression. And then we'll have a line that'll fit data. But since every single thing has had log applied to it, we're still in log space, so it looks funky. So we
Mhm.
want to unapply log. So we're going to anti-log to get back out. And now we have all of our stuff still has been approximated, but now it doesn't look so weird. Because I could
okay, I
take
understand.
y equals x, right? And if I apply log to every value in here, it's going to start looking strange. It's going to start looking like more of a curve. But if I do that once to make it look weird, I apply the inverse log, and now it goes back to exactly how it started. So that's why we have the anti-log. But yeah, I'm trying to figure out why the one in the lab doesn't look so nice. But shouldn't be too hard.
But this was the lab 24.
Yeah, I know. It's kind of weird, huh?
Yep, it sure is.
Because the log, the spot where log would be in 24 is blank. But really, I think based on your code, it looks just fine. It just kind of looks ugly. Like your code looks exactly fine.
So it's right.
I can't say because I haven't looked at 24 yet, as in grading.
Okay.
But just looking at your code, it looks fine. B0 plus B1 times the logarithm. That seems correct.
I mean, the rest of it is just the same. I just changed the equation.
Yeah, and that's kind of the point. All you have to do is change the equation. So
Right.
it looks weird, but again, the reason it looks weird is because we're viewing this thing that was done in log space outside of
Uh-huh.
log space.
Yeah. Yeah, I see what you're saying.
And so in order for it to not look weird, we would have to take the domain and just apply log to everything to it. It's just, I don't remember what all the things that plug in, like list X1, list X2, list Y1, list Y2. So I wouldn't worry about it. It looks, there's no errors, and I can see what it's trying to do. You can see it's not actually just a line. It's kind of a weird thing like this. It's just smushed.
Yeah, there's so many data points. The
Yeah.
thingy never looks right, even on this one. But this one is fine.
But I mean, so you have two things that are approximations, right?
Yep.
And even if this doesn't look amazing, it still is one. So you are then asked which one do you like better, and I would probably say the linear one. At least I think it asks you which one you like better.
I think that's in homework.
Oh, okay.
Oh no, it's here.
I think the linear one did.
Doesn't
Oh, hey, everybody else left.
Can I stop sharing?
Yeah, if you want.
Okay, that clears my doubt. Thank you.
Yeah, no problem. Yeah. Again, I wouldn't call it. It's not like a really big problem. It's when you go applying functions like that, you're bound to find ones that don't work very well. It's kind of why the question's asked the way it is. Okay, well, I guess that's everybody. So I'll see you guys on Friday.